Problem 3-48. Find the formula for t of n for the arithmetic sequence in which t of 15 equals 10 and t of 63 equals 106. So first of all, when we say t of 15 equals 10, what we're really saying there is the 15th term in the sequence is 10. Along the same lines, when we say t of 63 equals 106, that means that the 63rd term in the sequence is going to be 106. Now this is important because it comes into play here when we're talking about arithmetic sequences. We know that arithmetic sequences have linear growth. Oops, sorry, I'm on the wrong tool there. They have linear growth. So one way you can think about this is it being a problem asking you to find the linear equation between these 2 points. The point 15, 10, because our input is 15, our output is 10, and 63, 106. So when we deal with arithmetic sequences, sorry, that doesn't look like an A. When we deal with arithmetic sequences, remember there's 2 things we need to find. We need to find the generator, and we need to find the 0th term. Well, these 2 things have a lot in common with our linear functions, because our generator is the same thing as our slope, and the 0th term is the same thing that we call our y-intercept. So we can use the similarities between these 2 concepts here to help us come up with our formula for t of n. So the first thing I would do here, if I was treating this like it was 2 points here, I would go ahead and find the slope between the 2 points. We know slope is equal to the change in the y, or the change in the x, or I know a lot of people know it as rise over run. So let's go ahead and see if we can come up with that ratio here, the ratio of the change in our y's to the change in our x's. I'm going to go ahead and do 106 minus 10, and we're going to do 63 minus 15. So the difference between our actual 2 terms here is going to be 96, and the difference between our actual term numbers here, so how far apart are they? We'll say one's the 63rd term, one's the 15th term, which means we are 48 terms apart there. Well, this can reduce down to 2 over 1. So we're saying every time we increase our term number, or go from our 2nd term to our 3rd term, or our 3rd term to our 4th term, we have to add 2 onto each term. So our generator is going to be 2. It's the same thing as the slope. Our 0th term, well, we could find that either by looking at counting backwards from our 15th term all the way down to our 0th term, or if we treat it like it's a linear function here, we could take it and we could use y equals mx plus b. We know that the generator and the slope are the same thing, so we could put in 2 for our m, and then we need an input and an output in order to solve for our y-intercept, or our 0th term. So let's take it and let's put in and up one of the 2 points. You can use 1510 or 63 106. I would use 1510 because the number is a little bit smaller, might be just a little less complicated when you're working through some of the numbers. So 10 should equal 2 times 15 plus b. Now we have this where we're just solving for that parameter, or our b here. 2 times 15 is 30. So we have 10 equals 30 plus b. We go ahead and we subtract our 30 from each side to isolate b, and we get b equals negative 20. So if we were going to write this as a linear function, it would look something like this. Y equals 2, which is our slope, times x minus 20. But remember, we're not asked for a linear function, we're asked for the sequence. And remember, there's a difference between linear functions and sequences. Okay, a sequence is going to use discrete data, where a function typically is going to have continuous data there. So we need to make sure that we rewrite this in the correct form here for our arithmetic sequence. So in this case, we're going to be looking at t of n is going to equal, and it really doesn't matter the order that you write them in, but I know that I like to start out with my 0th term, which means negative 20. And all I'm doing each time here is I'm adding 2 each time I move up a term. So 2 times n. T of n equals negative 20 plus 2n. If I want to check it, I could take it and I can plug in either of my values here to make sure it works. If I want my 63rd term in the sequence, I'm going to say t of 63 should equal negative 20 plus 2 times 63. So 2 times 63 is going to be 126. When we add a negative 20 to 126, we're going to get that our 63rd term is 106, which is what we started with. So we know we have the correct formula for t of n. Hope this helps. If it doesn't, please make sure you ask your teacher.